See, here we will talk about the horizontal range in projectile motion. See here, if a body is projected with initial velocity u from the initial point where it will touch the horizontal surface, so this is the horizontal range. Suppose angle of projection is theta, initial velocity of projection is u. So I have told you horizontal component of velocity is u cos theta. Vertical component of velocity is u sin theta. Horizontal component u cos theta is constant each and every point because no horizontal force is acting. Vertical component varies. Time of flight we have found what will be the time of flight? Time of flight for horizontal motion will be 2u sin theta upon g. What will be the horizontal range? See here, actually horizontal range is equal to horizontal velocity because no force is acting. That's why horizontal velocity into time of flight. Horizontal component of velocity, horizontal component of velocity into time of flight. So this will be the horizontal range. To see here, u cos theta is the horizontal component and time of flight is 2u sin theta upon g. If you are solving, it will come u square 2 sin theta cos theta upon g, or you can say it u square sin 2 theta upon g. So see here, formula for horizontal range is u square sin 2 theta upon g. See here, if you are changing the angle, this time I have changed angle taken theta. If I am changing the angle, theta I have reduced. So what will be the horizontal range? If I am increasing the angle, what happen? This will be like that. Mean horizontal range depends upon angle of projection and square directly proportional to square of initial velocity. If initial velocity I am taking same, then that time horizontal range depends upon angle of projection. Here in the formula you can say it will depend upon the sine 2 theta. So see here, when horizontal range will be maximum, horizontal range will maximum. So see here, when it will maximum, if u is constant, you have taken fixed, then that time it will depend upon sine 2 theta. So when sine 2 theta will be maximum, so we know sine value sine value varies from -1 to +1. The numerical value when it will maximum sine 2 theta is maximum value is +1. So here for maximum range, for maximum range, what happens? Sine 2 theta, that should be 1 maximum value, and sine 2 theta will be maximum value of sine at sine 90 degree. So see here, 2 theta will be 90 degree or theta is 45. So maximum range, if you want to find the maximum range, different angle you have taken, then range will be maximum when angle of projection will be 45 degree. And what will be the maximum value? If you can see here, this r maximum will be sine 2 theta will be maximum, or you can say theta will be 95. The 2 into 45, theta will be 45 upon g, or you can say u square upon g. So this will be the formula for maximum range. what will be the maximum range? Maximum range will be at angle of projection 45 degree, and the value of maximum range will be u square upon g. Achha, one thing more. What we have seen, if we have taken different angle of projection, sometimes we have seen for different angle of projection range will be same. What we have seen, suppose I have taken one angle theta, this will be the range. I have taken another angle theta or phi, also that time I have seen range is same. This angle is theta. Suppose another angle what we have taken, that angle is phi. At both angle we have seen range is same. What will be the relation between this theta and phi? Okay, I want to tell what will be the relation. To see here, for the same range, see here, for same range, see, when I have angle taken angle of projection theta, so r is equal to what? U square sine 2 theta upon g. Another angle I have taken phi, that time also range is same. When angle of projection is here, theta is angle of projection. Angle of projection. Next time I have taken phi as angle of projection. Phi is angle of projection. Range is same. So r is equal to u square sine 2 phi upon g. If theta and phi different, theta is not equal to phi, and range is same. Range is same. Here you can see range is same mean what happened? U square sine 2 theta upon g is equal to u square sine 2 phi upon g. U square cancel, g cancel. You can say sine 2 theta is equal to sine 2 phi. Theta is not equal to phi. What do we have to do? We have to convert it in the form of, we know sine 180 minus 2 theta is also sine 2 theta. Sine 180 minus trigonometry, we know sine 180 minus theta is equal to sine theta. If you are applying this theory here, so you can see sine 180 minus 2 phi. If you are comparing here, so 2 theta is equal to what? 180 minus 2 phi. Because theta is not equal to phi, that's why I have converted into another form. Here you can see theta is equal to divided by 290 minus phi. Or you can say phi is equal to 90 minus theta. See, if one angle is theta, another angle is 90 minus theta, that time range will be same. So for same range, what we have seen? For same range, what happened? Angle of projection is theta or 90 minus theta. If you are projecting an object at an angle theta or projecting at 90 minus theta, range will be same. We can give some example also. See here, if I am taking different angle of projection, suppose I have taken angle of projection is 30 degree. This 30 degree I have taken 30 degree. I have taken 60 degree angle of projection. I have taken as 60 degree. What we have seen, 30 degree and 60 degree, both range will be same. 30, 90 minus 60, sorry, 90 minus 30, 60. So 30 or 60. If you are taking 30 or 60, range will be same. If you have taken 15, you have taken 75, range will be same. So for same range, if you are taking angle of projection theta and 90 minus theta, the range will be same. This here I have shown you 30 degree, if range will be this R, so at 60 degree also range will be same. And for maximum range, I have told you maximum range theta is equal to 45. If you are projecting a body at 45 degree pi by 4, then range will be maximum. You can see here, if I have projected a body at 45 degree, so that will be the maximum range. So this maximum range is for 45 degree. This is the R maximum. Maximum range will be for 45 degree. You can see here for the horizontal range, what I have told you, formula for range is u square sin 2 theta upon g. Range directly proportional to square of speed, initial speed or initial velocity, magnitude of initial velocity, and it depends upon angle of projection. Formula is u square sin 2 theta upon g, and I have told for maximum range theta is equal to 45, and for same range if you are taking different angles, different angle of projection, so I have shown you their relation is they are complementary angle. They should be complementary angle. Mean if one angle is theta, then another angle should be 90 minus theta. Angle of projection you have taken theta and 90 minus theta, range will be same. So one thing more I want to show you. For same range, what we have seen, suppose we have taken different angle. I have taken one angle is theta, another angle is 90 minus theta. See here. See, formula for range is u square sin 2 theta upon g. Formula for maximum height is what? U square sin square theta upon 2g. See here, I have told you, if you have taken different angle, complementary angle. Suppose I have taken angle theta. I have taken 90 minus theta. Two different. One angle I have taken theta. Another angle of projection I have taken, this is 90 minus theta. Range is same. What is the relation between time of flight? Time of flight will be different. For this projectile motion, time of flight will be more. For this, time of range will be same, but time of flight will be different. Also you can see here maximum height. Suppose this maximum height is h1, so maximum height for this is different. This, suppose this is h2. Different maximum height. One is h1, another I have taken as h2. See here, what will be the relation between? Time of flight is t1, time of flight is t2. What will be the relation between h1, h2, between t1, t2? Mean when range will be same, what will be the relation between time of flight and relation between maximum height for the same range? Same horizontal range. Same horizontal range or relation between time of flight, relation between maximum height. So here firstly we will see relation between time of flight. Let two different time of flight are T1 and T2, and two different maximum height are H1 and H2. For same range, angle of projection 1 for first projection is theta. For same range, second projection should be complementary angle, that is 90 minus theta. So here angle of projection should be theta and 90 minus theta for same horizontal range. For same horizontal range, angle should be theta and 90 minus theta. What will be the T1 for first? What will be the T1? T1 is equal to what? 2u sin theta upon g for first. For second one, what happened? T2, 2u sin, here angle is 90 minus theta, that's why 90 minus theta upon g, or you can say 2u cos theta upon g. T1 and T2. What will be the range? Range for the same, this is u square sin 2 theta upon g, or you can say u square sin 2 theta is what? 2 sin theta cos theta upon g. So what will be the relation between these? T1, T2 and range. If I am multiplying T1 to T2, T1 into T2, see here 2u sin theta upon g multiplied by 2u cos theta upon g. Rearrange this. 2 I have taken here u into u square. 2 cos theta sin theta. So 2 sin theta cos theta upon this g into g square I have taken as g into g. So see here, 2u into u square, 2 sin theta cos theta, g into g. So see here, what will be this? So you can see here, this will be the horizontal range. So this T1, T2. This T1, T2 is equal to what? 2r upon g. Very important. For the same horizontal range, if T1 and T2 is the time of flight for that two motion, if different angle of projection is there, so T1, T2 is equal to 2r upon g. Also you can say product of time of flight is directly proportional to किसके होता है बेटा horizontal range. तो one relation I have found it. एक relation मैंने find out किया T1 और T2 के बीच में, and that relation is what? T1 T2 is equal to 2r upon g. Same way I want to find the relation between maximum height. What will be the relation between these two maximum heights? Same thing I will do here. I will take maximum height. Okay. Maximum height. H1. Formula is what? U square sin square theta upon 2c. So first angle of projection is theta, so u square sin square theta upon 2g. For second, u square sine square, there is 90 minus theta upon 2z. That will become u square sine 90 minus theta is cos theta. So that is cos square theta upon 2z. Same thing we have to do. Multiply this. h1 h2 is equal to what? U square sine square theta upon 2g multiplied u square cos square theta upon 2g. Slightly rearrange in the form of this. See here, if I am squaring that, what happened? U square 2 sine theta cos theta upon g square. So that will be u power 4, 2 2s are 4 sine square theta cos square theta upon g square. Because all are in square form, to convert in this form. So see here, sine square cos square theta is there, u power 4 is there, g into g square is there. Only we know 4. So I have multiplied by 4 up and down. So see here, u square into u square, that is u power 4 sine square theta cos square theta, g into g square, in downward 2 into 2, 4 into 4, that is 16. So see here, this u square 4 sine square theta cos square theta upon g square, this total you can write as r square. Here to here, from total, this can be written as what? R square upon, that is 16. So one relation you have found it. H1 H2 is equal to what? R square upon 16. Here also you can see here H1 H2 is directly proportional to R square. The product of different height for same horizontal range, H1 H2 is directly proportional to R square, or H1 H2 is equal to R square upon 16. Also you can say R square is equal to 16 H1 H2, or also you can say R is equal to 4 under root H1 H2. So this is the relation. Here I have found the relation between maximum heights for same range at different angle of projection. What you have seen, H1 H2 is equal to R square upon 16, and T1 T2 is equal to 2R upon G. The result to what you have found it, T1 T2 is directly proportional to R, H1 H2 is directly proportional to R square. The very important relation is there. Remember it. They are asking objective questions. If T1 T2 are different time of flight for the same range, so T1 T2 is 4 options they will give: proportional to R square, independent of R, proportional to R, proportional to R cube. The relation is what? T1 T2 is proportional to R, and for H1 H2 they are proportional to R square. So this is the things you have to know about the horizontal range, and maximum horizontal range will be for angle of projection is 45 degree. You have also seen sometimes when a player kick the ball, if angle of projection is nearly 45, okay, so that time horizontal range will be maximum. Or sometimes you can see when they are throw the ball, कभी कभी अपने बेसबॉल एंड सारे different competitions में देखा होगा, भाला फेंक, गोला फेंक, ठीक है, like that competition what you have seen कि if angle of projection they have taken exact 45 and nearby 45, then that time range will be maximum. If slight come down or up and down to 45 से up हुआ, 45 से down हुआ, तो उनकी range कम हो जाती है. तो they have to practice. अगर तुम ध्यान से देखोगे तो उनका एंगल ऑफ प्रोजेक्शन क्या होता है, नियरली 45 होगा या एग्जैक्ट 45 होगा, उससे उनको क्या होता है, मैक्सिमम रेंज मिलती है। तो हमेशा ऐसे प्रैक्टिस करते हैं, भाला फेंक, गोला फेंक वगैरह जो भी हैं प्लेइंग गेम्स हैं, कि एंगल कितना हो, एंगल ऑफ प्रोजेक्शन रेंज अगर मैक्सिमम चाहिए तो उनको क्या लेना पड़ता है बेटा, 45 डिग्री, नियर बाई 45। ऐसे ही अगर कभी आप देखो क्रिकेट वगैरह में, तो कभी कभी प्लेयर्स क्या होते हैं, बहुत ही कम वेलोसिटी में भी सिक्स मार लेता है, ठीक है, धीमे से पुश करता है, सिक्स चला जाता है। ध्यान से अगर देखोगे, इफ एंगल ऑफ प्रोजेक्शन इज नियरली 45, तो उस समय रेंज ज़्यादा होती है, आराम से सिक्स के बाहर, मतलब बाउंड्री के पार चला जाता है, सिक्स होता है। लेकिन कभी कभी आप देखो कि एंगल ऑफ प्रोजेक्शन 75 हो गया, 85 हो गया, तो यू हैव टेकन मोर वेलोसिटी, आपने बहुत ज़्यादा वेलोसिटी भी दी, फिर भी गेंद क्या होती है, बाउंड्री पार नहीं जाती, आसपास ही रह जाती है, ठीक है, बाउंड्री के पहले ही गिर जाती है। क्यों? क्योंकि इफ एंगल ऑफ प्रोजेक्शन विल बी मोर, रेंज विल बी लेस। 45 पे मैक्सिमम रेंज होती है। अगर आपने एंगल ऑफ प्रोजेक्शन 80 कर दिया, 85 कर दिया, ठीक है, तो उस समय आप कितनी भी वेलोसिटी दे लो, रेंज क्या होगी, वेरी वेरी स्मॉल हो, वहीं का वहीं क्या होता है बेटा, फॉल डाउन गिर जाता है। आपने देखा होगा क्रिकेट वगैरह, अदर्स गेम्स वगैरह में, तो अगर मैक्सिमम रेंज चाहिए तो आपको 45 या नियर बाई 45 यू हैव टू प्रोजेक्ट। Today we will discuss about the velocity of the projectile at any time. See, what will be the velocity at any time or at any point of trajectory of projectile? So see here, what we have told earlier, if velocity of projection is u, initial velocity, u cos theta is will be the horizontal component, and u sin theta will be the vertical component. Horizontal motion, vertical motion, in horizontal motion acceleration is 0, in vertical motion acceleration is minus g. Suppose after time t, particle reach at point p. I have told you, if there is no horizontal acceleration, mean horizontal component of velocity will be same each and every point. Here also horizontal component will be u cos theta, at this point also this is u cos theta, each and every point horizontal component will be same. Here also horizontal component will be u cos theta, so each and every point there is no horizontal force, that mean horizontal component of velocity will be same each and every point. Suppose at point P, what will be the velocity? We have to find the velocity of the projectile at point T. What will be the two components of here? Suppose this is the horizontal component Vx. Vx is also equal to what? U cos theta. What will be the vertical component? So see here, let particle reach at point P in time t after projection. V is the velocity. V is velocity at point P. So see here, V is equal to what? Vx I cap plus Vy j cap. Vx will be the horizontal component, Vy will be the vertical component. So see, a horizontal component of velocity at point P, that will be u cos theta. For vertical component, vertical component V is equal to what? V is equal to first equation of motion, V is equal to u plus at. So Vy is equal to what? Uy plus ayt. What is initial velocity? Uy is equal to u sin theta, and ay acceleration is minus gt. You can see here, Vy is equal to what? Vertical component at point P, that is u sine theta minus gt. So see here, we have to find net velocity at point V. What will be the velocity at point V? Horizontal component you know, vertical component. If you want to write in vector form, so that will be u cos theta I cap plus u sin theta minus gt j cap. What will be the magnitude? The magnitude will be under root vx square plus vy square, that is u cos theta square plus u sin theta minus gt square. Solve this, you can solve it, that is u square cos square theta, here u square sin square theta minus a minus b का whole square, a square minus 2ab 2u gt sin theta plus g square t square. Also we can write here what will be the magnitude of velocity. U square will take common, cos square plus sin square is equal to 1. That is u square cos square theta plus sin square theta is equal to 1 minus 2u gt sin theta plus g square t square. So this will be the formula for velocity at any instant. What will be the velocity at any instant? You can see here u square minus 2u gt sin theta plus g square t square. So this is the equation for velocity, value of velocity at any point of projectile or at any instant. What will be the angle made by this velocity? Suppose this makes angle alpha with the horizontal. So see here, if net velocity makes angle alpha, what we know, tan alpha is equal to what? Vertical component upon horizontal component. I have found horizontal component is u cos theta, vertical component what we have, Vy is equal to uy plus at, that we have found u sin theta minus gt. If you are putting here the u sin theta minus gt upon u cos theta, so this velocity makes an angle with horizontal, so that will be tan inverse u sin theta minus gt upon u cos theta. So this will be the angle made by velocity vector with the horizontal, and this is the magnitude. V is equal to u square minus 2ug t sin theta plus g square plus t square, g square into t square. Next I want to discuss about the energy. What will be the energy? Kinetic energy, potential energy, each and every point of projectile. See here. See here, we want to talk about some energy relation. See here, suppose I have taken this horizontal surface, potential energy is 0. I have supposed, actually potential energy will not 0. If it will from some height, our potential energy at our surface, it is also minus gm into m1 r. So that I will not consider, only I am comparison study I am going to consider. So suppose at origin, let at origin O potential energy is 0. Potential energy is equal to 0. What will be the kinetic energy? Kinetic energy at point O will be How much kinetic energy will be here? You can see here where this speed is u. You can see here kinetic energy will be half m u square. M is mass of particle. The total energy you can see, total energy at origin is equal to potential plus kinetic, so that is 0 plus half mu square. See, when we will talk about the highest point position, A, at highest point position or maximum height position A, what happened? What will be the energy at that time? You can see here, what will be the velocity? The net velocity at point A. Velocity at point A is u cos theta, because here vertical component is 0. There is no vertical component. Vertical component here is 0. Only horizontal. So net velocity at point A is u cos theta. So what will be the kinetic energy? Kinetic energy at point A. So this will be half m u square cos square theta. Here some students are confusing. They are thinking that at highest point velocity will be 0. No, here at highest point velocity will be u cos theta. तो कुछ बच्चों को कन्फ्यूजन रहती है कि हाईएस्ट पॉइंट पर वेलोसिटी 0 होगी एंड काइनेटिक एनर्जी 0 होगी. ऐसा नहीं होता. प्रोजेक्टाइल मोशन में एट हाईएस्ट पॉइंट आर यू कैन से जो मिनिमम काइनेटिक एनर्जी होगी that will be what, half mu square cos square theta. And potential energy, तो potential energy अगर find out करना है तो we can subtract from the total energy by law of conservation of energy. What happened? Total energy will be same. So you can find by two method, mgh also you can apply. You can take maximum height or from total energy minus, mean half mu square minus half mu square cos square theta. You can find half m1 minus cos square theta, that is half mu square sin square theta. So this will be the potential energy at point A. So kinetic energy at highest point half mu square cos square theta, and potential energy half mu square sin square theta. Again, if we'll reach at point at on the ground, so that time also at point B or ground. At point B, or again you have reached at the ground. Again it will becomes potential energy 0, and kinetic energy will be half u square, because velocity will come same. Here also you can see what will be the velocity. Velocity will be, net velocity will be u. Vertical component will be u sin theta. This is upward, here this is downward, here minus u sin theta, and u cos theta will be the horizontal component, and net velocity will be u. Suppose if potential energy is not 0, then what happen? Here total energy will be u plus or any u, capital U plus half mu square. Here u plus half mu square sin square theta, and kinetic energy only you will add the potential energy u, which will be at point O. अगर सपोज करिए पोटेंशियल एनर्जी हम इनिशियल 0 नहीं लेते, ये पोटेंशियल एनर्जी एट पॉइंट O is u. Kinetic energy will be half mu square. So total energy will be at point O The total energy at point O, so that will be U plus half m U square. This will be the same. At highest position, what happen? At highest position, if you'll see, at highest position, so that time what happen? U will be added here. The potential energy will be U plus half m U square sin square theta, and the kinetic energy will be half m U square cos square theta, and total energy will be sum of this U plus half m U square sin square theta plus half m U square cos square theta. So same thing will be there. A potential energy U will be there, and you can change or you can convert, and or you can find the energy at any point in the projectile motion.